First and foremost, introduction. Ultrasonic sensors are used in variety of technical fields. In automation, robotics, and instrumentation, no contact distance measurement is extremely valuable. Ultrasonic sensing is one of the most reliable ways to sense proximity and detect levels. An ultrasonic sensor is a device that uses ultrasonic sound waves to determine the distance to an item. The ultrasonic sensor, which is known as transducer, works in the same way that a radar system does. Electrical energy can be converted into acoustic waves and vice versa using an ultrasonic sensor. The acoustic wave signal is the high-frequency ultrasonic wave that travels over 18 kHz. Next, I will briefly explain our flow chart. As shown here, I represents the counter increment. Therefore, it counts the total movement that the sensor will move. For as long as the counter doesn't reach 10 times, the sensor will move 180 degrees to the left, and if there is any object detected, red signal will be shown in the radar. And then, moving to the right side for another 180 degrees with the same process until it reaches 10 times.
System description. The system is made up of a simple ultrasonic sensor mounted on a servo motor that rotates at a specific angle and speed. This ultrasonic sensor is connected to Arduino digital input-output pins, as is the servo motor. This is an object detection system that employs radio wave to assess whether or not there is an obstruction in a 180-degree viewing angle. The Arduino Uno will serve as the messenger for the processing application in this setup. The ultrasonic sensor will use radio wave to identify an item, and the servo motor will spin the ultrasonic sensor to 180 degrees. When the ultrasonic sensor detects an obstruction, the processing application will display a red region where the impediment was identified. List of materials. First, Uno Arduino, ultrasonic sensor, micro servo, breadboard, male-to-male jumper wire, male-to-female jumper wire.
This is our diagram for ultrasonic sensor project. As we can see here, the component we use is ultrasonic sensor, servo, push button, and Arduino Uno. For ultrasonic sensor, we will set the trigger pin and echo pin at pin number 10 and pin number 11, while for servo, we will set the pin at pin number 12. For push button, we will set the pin at pin number 5. As we can see here, to rotate the servo from 0 to 80 degrees, we will use void loop command, and this is the coding that we need to insert inside the loop command. Next, this is the coding for calculate the distance measured by ultrasonic sensor. To transfer the data from Arduino to Visual Studio, we will use this command which is serial begin and serial print. Next, after we already create the coding in Tinkercad, we need to verify it at Arduino IDE first to make sure either the coding can be read and function correctly or not. Okay, as we can see here, this is the same code from the Tinkercad that I already copied and paste it here. After that, we need to verify the code first to see if there are any error. As you can see here, there is no error, and then we upload the coding to see either it correct or not. So from here we can see that the coding is correct since the servo will start to rotate. Next, we move to the Visual Studio. So this is our form for ultrasonic radar project. We have detect object button, stop detect object button, the label, and this is the picture box. The pictures box will show the result of the project, which is the radar, and we also need the serial port. This serial port will transfer the data from the Arduino Uno to the computer. Next, this is the GUI for our project. As you can see here, this is for button detect. This is the coding that we need to use. Also, the public partial class, we need to use this coding to describe everything. And this is the coding that we need to use for serial port data receive. For create the radar, we will use this coding to create the data, to create the radar. And if we run the GUI, we will get the form looks like this. The form will look like this. This is the radar and this is our detect object and stop detect object button. So this is the output of our mini project. If the ultrasonic sensor detect the object, the red line will appear inside the radar.
Here is the systematic diagram for the Prote software. As you can see, the Arduino Uno were connected to the ultrasonic sensor and the virtual terminal. The output here is we can see the distance measurement of the object. In conclusion, this tool can be custom made to fit various applications such as being fitted in cars to aid when reversing, could tell the level of water in a well or storage tanks, for example. The technique can also be implemented with the GCM for proper remote monitoring. The technique can also be recommended to be used in the tunnels, such as trains or vehicle tunnels, to give signal in case there are complications. The objective of this project was to design and implement an ultrasonic distance measurement device, as described in this report. System is developed that can calculate the distance of the track object. With respect to the requirements for an ultrasonic range finder, the following can be concluded. First, the system can calculate the distance of the obstruction with sufficient accuracy. Second, the device has the capability to interact with ultrafibber if used as a secondary device. The third, this can also communicate with PC through its serial port. And the fourth one, this offers a low-cost and efficient solution for non-contact type distance measurement. The improvement that we can make is the range can be considerably increased by using high-power drive circuit. First, using temperature compensation, it can be used over wide temperature range. Second, increase the number of moving objects that can be detected. And the third one is expanding the range of tracking moving objects. That's all from us. Thank you.